So users have their funds on chain in DeFi, and you have these big hacks which take millions of dollars away from these users. And Quint is a formal specification language which recently safeguarded $23 million in user funds. So using Quint, you're able to make sure that these potential hacks are mitigated. And so I guess please talk about a quick intro about what is Quint, what is formal specification, and then we'll talk about this more in depth.
Okay, great. Thanks for inviting me. So Quint, I guess us as programmers, when we have problems we're trying to solve, we often think of a solution and like, oh, this is great, but does it work in every scenario? Like, is there maybe something I'm not considering? Is there some scenario, some combination of actions that won't succeed in this like solution that I just invented or that I've heard for someone else? So I guess for every programmer, this is something that we do. We come up with solutions. And usually, like when we are just starting, when we are beginners, we're super confident. Like, no, for sure, this is going to work in every scenario. And then with experience, we kind of like come to realize that it's hard to predict, especially like in distributed systems where so many things can happen at the same time. Um, so there is where Quint can help because Quint helps us think about all of the possible scenarios. It helps validate a solution where we are not perhaps super confident about, or even if we are confident about, are we willing to bet millions of dollars in the solution? And Quint can help with that because Quint and any other formal specification language, like formal specification languages in general, they help with this problem. We formalize some solution, and then there are tools that can help us reason about all the possible scenarios from our formalization. So we write like our system, like my solution does this and that, and I expect that this property will be held. Like I expect that no user will lose funds in this migration, like in the neutral migration that you talked about. Um, so we write that, and then there are tools that will check every single possible scenario for us and tell us for sure, like your solution satisfies its properties in every possible scenario. So it really helps us get more confidence in solutions, but also helps us reason about the solutions and learn more about them. So it's also like it kind of for me and for other people that are using Quint for a while, when we get like the hang of it, it kind of becomes your next pen and paper because when you're thinking about something complex, you just want to go to Quint and then write it down there, and then it can help you like observe some scenarios. You can play with simulation. You don't have to go straight to formal verification. So it is also becoming a tool to help us understand, navigate complex problems, complex solutions. But it is a verification tool. So there's these two aspects of it. It helps us understanding, but also gives us formal verification. And it does so by inheriting some semantics from another specification language called TLA plus. So it's heavily based on TLA plus and just makes things more usable. Because usually, if you go to formal specification languages, they're super hard to learn and to use. And Quint is not. Quint is much easier. That's the whole goal. But we do inherit much of the like mathematical aspects and semantics of TLA plus, and therefore we are able to provide like formal verification and not just play around.
So like DeFi is like completely open. Anyone can submit transactions. Anyone can read the code. It's all open source, and there's like money there. And so then, like these complex contracts sort of seem safe. They like work, but formal verification is like sort of testing every single, or when you test for a scenario, it just like what I'm thinking is runs a whole bunch of different tests with random numbers on every single account and make sure that there's no when you're testing for a scenario that sort of funds cannot get hacked or stolen. Is that like a nice overview?
Yeah, it kind of is. You said random, and the thing about the formal verification part is that it is not random. It will test every single possibility. It might seem impossible if it's state like this, like I will test every single possible amount. But Quint will let you define like the scope in which you want to test all the possibilities. And then, so for instance, I want to test all the possible transfers that I can do for you, or that Alice can do for Bob. And Quint can leverage some existing tools that use the SMT solvers, which are kind of like the tool perhaps most commonly used in formal verification for crypto. But as the SMT solver will not like by hand try each value. Oh, I do a transfer for one, and now I'll do another one for two, and now another one for three. It's not like as simple as that. It will translate that into mathematical formulas and solve that using math. So like, is there a value I can put here instead of x that solves this equation? So in some instances, it can actually do some stuff that's really amazing that we would not think it's possible. In some instances, it is also like not feasible to check all possible scenarios, right? Because it's too much. So the hard part about formal verification and in general is to reduce the scope to a point where you can actually get some guarantees. So that's a skill you have to learn and probably like the hardest part of it. But you can still get advantages of using this before going to full formal verification. You can still do the simulations, as you said, like random numbers, right? So that's super easy to do. And as you said, in crypto, like in DeFi, everything can happen anytime because there's millions of users that can do millions of different transactions. So there's like a bunch of possibilities that can happen. Like right now, like so many things can happen. And the way we model that is called like this is a source of non-determinism. So non-determinism, like perhaps people will remember from like school or something, but it's when there is something we cannot control, we cannot predict. So if you throw a dice, that's non-determinism because you can get some value there that you cannot program. Like, no, I will get three. No, you don't know if you get three. So it's a source of non-determinism. And also distributed systems, the order in which some processes will execute. Like if two processes are running in parallel, you can also not predict in each order they will execute. So there's also non-determinism. And the users doing transactions in DeFi is also something non-deterministic. You cannot control what Alice will submit now. So we say like one of these things will happen, either like a transfer or a withdrawal or a deposit, either from Alice or Bob or Charlie, either from $1 or $100. And then we model this stuff, and then the Quint simulator or the formal verification part, which is the model checker. The simulator will run a bunch of random ones as much as you want, and the model checker will run all of them.
Oh yeah. I think before we get into like the super technical stuff, first of all, just talk about you, informal systems, and sort of just a general intro and how you got into sort of working on Quint.
Okay, good. Yeah. So I guess my story starts when I was doing like my bachelor's in computer science, and I needed like a subject to do my bachelor thesis on, and then someone presented me TLA, like a colleague just presented me TLA plus, which is another formal specification language, and I loved it. So I like jumped right in and started doing my bachelor thesis around some tooling for TLA plus, and then I continued on my master's to also work on that. And then I knew informal systems when I was during the COVID-19 pandemic. I joined like an online conference for TLA plus stuff. And that's when I met like informal systems was presenting work on TLA plus because informal systems also used to use TLA for specifying like the Tendermint protocol and I guess some other IBC stuff. They were also using TLA plus for verifying that at the time, and also for test generation, which we can talk about test generation later. So I saw the work there and I thought it was amazing, but I never considered the possibility of me working for them. But then on the next year, on the next TLA conference, I presented my own work for my master's. And then it turned out like I was working on the same thing that Informal System was working on for model-based testing generated from TLA plus models. And then someone from Informal reached out and asked if I wanted to join or if I wanted to talk to them. So that's kind of how I started. Informal Systems was developing a model checker for TLA Plus for years. So we have a very stable model checker called Apalache. So I joined the Apalache team. I was helping them build this model checker for formal verification. But then they presented this idea of like a new language, like people here inside Informal are struggling so much, like with TLA Plus, no one likes it. It's just so complicated to learn. People give up. People don't want to read our specifications. So we had this idea for a new language that would look something like this. What do you think? Do you want to work on this? And I was like, oh, that's amazing. Because I actually had worked with programming language development a bit academically before, and I thought it was amazing. So it was kind of like I was very lucky to get some intersection of two areas that I liked a lot, which was like TLA plus informal verification and also programming language development compilers. Um, so yeah, so I jumped right in, and it was mostly me working on Quint for the first year, and then more people came to help, and now we have something that really works and many people are using. I guess many people, like in not many people, but more than I expected, I guess. And yeah, so that's how I ended up at Informal. Informal is using Quint mainly for protocols. So we developed a bunch of protocols inside Informal. We recently just launched Malachite, uh, which is a BFT consensus engine, and it's super complicated. And people are using Quint to reason about the things. They're like, oh, what if we add some processes that does this in this protocol? Then they first draft it out in Quint, see how it looks, see if the properties are satisfied, and then go and implement it in Rust. And also we use Quint for audits, for security audits, as in the Neutron case you talked about earlier. So as in our audit offering, we also include, like, we can write Quint models for you and help you verify stuff, and generate tests for you from Quint. Um, so I guess from informal, that's it. And then for me, I'm working mostly as like the lead developer of Quint right now, and I also started teaching formal methods at the university. So I'm like a temporary lecturer. I teach classes there. It's been doing that for a year, and it's been fun. So I've been learning more about that kind of stuff, and I'm teaching both Quint and CLA Plus for my students, and it's very fun to see uh, they get like to learn the benefits from it, and they're very excited. So yeah, yes, that's it.
Nice. I guess formal verification isn't necessarily like a crypto thing. It's not like crypto specific. Could you talk about formal verification, sort of the, I'm assuming, for my understanding, formal verification was always like a more academic thing of like we use fancy math to like make sure this is secure. Is that true? How does that sort of apply to crypto? And then also, could you add a little bit about informal systems, like the name itself? I thought was cool. Anyways, so
Okay.
talk about all that.
Yeah. Yeah, I think you're right. Like, it comes from a very academical field, and it's one of, I think it's still to this day something that academics are still trying to convince industry people to use. So it's definitely not mainstream in the industry, like as a whole, not in crypto, not in other areas. So it's still something that's in that convincing stage. It does make sense because it's often costly. Like, it's not that something that you get for free. It's not like a program you download, click a button, and then it will say that your system is verified. It takes work. Um, I guess that this type of form of verification that we are doing here, which is through model checking, is the most accessible one, the one that takes less work. If you see, there are some, like, even crypto projects using more advanced stuff like proof of systems, where you hear of Coq, Lean, maybe like Agda, Idris, Daphne. Those tools, they take much more work than Quint and CLA, because you have to actually manually write a proof. uh, there is some like tools to help you do that, but you still have to think about the proof steps yourself. So it takes like much more expertise to do that. While in Quint, you just have to write your model, your solution itself, your algorithm. You don't have to write the proof. Like, the model checker will take care of the verification for you. So it's much more automated. But still, like, it takes a bit of work. And convincing people to use tools for security is not the easiest. It's kind of like, why will they spend money on this? This doesn't make, it would put, sorry, it will not bring anything back to me. So it's hard to convince people to use it. But what happens is that the parts of the industry that are more like delicate, or they're more risky, or maybe the risk will uh, result in a higher, sorry, uh, the areas of the industry where the something wrong happening would result in a higher problem. Like in crypto, if something bad happens, people lose a lot of money. And like health software, like if something bad happens, someone can die, or like in avionics, like if your software controls an airplane, something bad happens, then people can die. So usually when people can die or if people can lose a lot of money, that's when formal verification applies the best, just because it justifies the cost much better. Um, so yeah, so people have been using formal verification in like avionics and in health software for a while now, but it's much more niche. Like there isn't like billions of so sorry. It's much more niche because there's like for crypto for DeFi there's like millions of like D apps and app chains and whatever. There isn't millions of software for airplanes, right? There's I don't know a handful of them. I don't know, but that's definitely like okay. At some point in the past, someone went there, verified that software, and they're still running the same software for decades. So there isn't really like a lot of jobs in there. Like if you want to work with formal verification, you'd be very lucky to be hired like in avionics because there isn't like a lot of demand. But they are using formal verification in avionics. Um, and like more recently, I guess in the last 20 or 10 years, uh, TLA Plus is becoming more popular, and companies like Amazon have been really like doubling down on TLA Plus. They published a paper about how they are using TLA Plus for like tens of different projects, and how it did help them find bugs in a couple of them, but mainly it also helped them do more aggressive optimizations. And how does that work? It's just like do you know when you're writing a software and then maybe like you have something in there and you look at it, or someone else wrote the software and you look at it and like, do I really need this piece of code in here? Is it really doing something? Can I maybe just switch it to another stuff? Would it still work if I did that? And then you don't know and you're insecure and then you don't do it. But if you have a formal specification of your solution, then you can just go there and switch to what you think is more optimal in the formal specification and check if for every single scenario it still works, it still satisfies the property. And then if it say yes back, it responds yes, it does satisfy the property even with this optimization, then you go into production and you make that optimization safely. So it enabled Amazon to do those kinds of optimizations on like mainstream software. Um, yeah, so I guess it's definitely industry speaking up. And for crypto, I think it applies mostly because of how much money people can lose and how much trust you have to put into the software. Uh, and also because there's a lot of like opportunity in this industry. So to be honest, like even since I was like doing my master's, I knew like probably if I get a job in formal methods, formal verification, it will be in crypto. And that's the reality for most people in academia research those areas. So that's I think why you see so much research work in formal verification around crypto is just because it's worth to use formal verification in crypto because there is a lot of money to be lost, and there is also like enough money to invest in this research, which is often not the case for other areas where it would also be worth having formal verification. Like, at least that's my view. And from informal, I was not there when the company name got chosen, but I think it's more of a joke because it really started as a niche of formal verification people. Like it formally started as a group of like how do you call it, like the dream team. So they picked like the dream team from people doing some awesome research and started a company. And those people are mostly doing research with formal verification, and they just started like right away using a bunch of TLA plus. So I think it's more like a joke uh, with the like a very formal verification team and then this informal systems, and I love it. I have a hoodie that on the back says "formally informal," and yeah, I love it. I use it on class with my students, and it's nice.
For I guess formal verification from my understanding. So we have like the complicated proofs and then you have sort of modeling, and TLA plus only does modeling. I need to understand better how TLA, what it works with or for, and then we'll like go later into like what Quint adds and offers. So
Yeah,
like
great.
an overview on Quint or on TLA plus.
Yeah, that's great. That's also how I like to approach this. Like, I think the easiest way to convince people that Quint is good is like first convince them that CLA is good, and then the second part is easy, that it's convincing that the Quint is better than CLA plus for programmers. Um, so yeah, so for CLA plus, basically, if you just Google CLA plus and look at any code written in CLA plus, it's math. Like syntax is very mathy. If you know latex, if you know latex and how like the syntax works, CLA plus is very similar to that. It was created by the same person, Leslie Lamport, who is the creator of text and also like the father of distributed systems. Um, yeah, so a bit of history about TLA Plus is just Lamport is like one of the smartest people alive. Uh, he was doing like, oh, what is Byzantine fault tolerance? Oh, what is Paxos, an algorithm that solves Byzantine fault tolerance? Like really smart stuff. And he was writing papers, really smart person. And he noticed how sometimes in his papers there was some like ambiguity. He would define something and it was not precise, it was ambiguous. And he was like, oh, if I'm this like super smart person and I am writing ambiguous stuff, like the others must be doing that as well. That's a problem. So he created TLA Plus just for that, just for writing papers in a more precise way. He didn't want it to do formal verification. He didn't care about model checking. He just wanted a language to be more precise, to do precise definitions of distributed algorithms. And that's what he was using for years. And he didn't even think that could be a model checker for TLA Plus. So like a tool that like parses TLA Plus and runs it like for all the possible scenarios and verify properties. He didn't think it was possible because he didn't think of that when he was creating the language. He just wanted like a precise way to write stuff. But someone came and wrote like a model checker, and of course he helped, but like he didn't think it was possible at first. But someone came and wrote a model checker for TLA Plus. It doesn't support all of the language, but supports everything that you need in practice. So yeah, they wrote a model checker, and then more companies like started using it, and they started using this model checker, which is the TLC model checker. So it is that's it. It's like a very mathematical language, and since it was not conceived like to be used as like a language like with automated tooling, it has some tooling is very like it's hard to make tools for TLA Plus. Like if it was easy, we would probably not develop Quint. We would just like add more stuff on top of TLA Plus, make it better. But it was really hard to make it better because it's super hard to write tools for TLA Plus, at least in our experience. So yeah, so it's the tools. It has like an old IDE that's they are trying to discontinue. But it's just like looks like any old IDE. The CLI tools kind of like are a bit clunky. They don't even they don't they sorry CLI tools are a bit clunky and they seem like they weren't made to be a CLI tool. It's kind of like a workaround. Now they have a VS Code plugin, which is great, but the tools were not made for that, so it doesn't feel like a normal VS Code plugin because if you type something wrong, it won't tell you. You have to click something and then it will tell you. So like the workflow is not as great. And the syntax, it's really mathy. Like if you like math, you love it. Don't try Quint if you like math. If you come from mathematics, if you're not a programmer, if you come from mathematics, or if you learn a lot of math before learning how to program, you'll probably like TLA Plus better. But if you're not, if you're a programmer, as most people trying to write TLA Plus were, then Quint might be much better because it's targeted at you. It's not targeted by like at what Lamport thought would be better at the time.
Yeah. Leslie Lamport's pretty legendary. I heard he like wrote all of like LaTeX in like while he was like in a cabin like for a couple of months or something, some story like that. I didn't know he started TLA Plus. And so I'm assuming that so it's really mathy. I want to get your take on sort of, before we get into Quint, sort of the languages that you use. So there's like this narrative that like Solidity is like less secure and like Rust is more secure. Could you talk about what languages are compatible with TLA Plus or formal verification? I don't really know how to like think about that, sort of just like the general understanding, and
I
then yeah,
I don't think
go
there's
for it.
nothing like it. If one answer would be latex. I think that this is the language that is closest to TLA plus, in the sense that there is no language like the programming languages don't do what TLA plus does, and also like Quint is not a programming language; it's a specification language. So the goal is different. They do different things. You can think about like HTML. You don't use HTML to write a smart contract, right? They have different goals. Um, so yeah, I don't think there's anything like TLA plus in terms of syntax. Then like LaTeX, perhaps it's the closest, if that makes any sense. But it's really math. You write it like as you would type math in LaTeX. Um, and yeah, I don't know what else to comment on that.
And for the, I guess, models, so could you describe like a model, how you would do it in latex or in TLA plus, and then sort of how you would make the same model in Quint? Like, what is modeling exactly?
Yeah, I can talk about modeling. For comparing the two, comparing TLA plus and Quint, I think it's a bit hard to do that by like just speaking, but I guess anyone can look up. We have some comparison in the Quint README, so if you want to look that up. But I can talk about what a model is. So a model is just a state machine. If you remember what a state machine is from school or wherever, state machines, you have circles and arrows connecting the circles, where the circles are states and the arrows are transitions. So you go from one state and then from another state through an arrow. So a simple example may be like traffic lights. If you think of a traffic light, you have like green, and then from green you go to yellow, and then from yellow you go to red, and then from red you go back to green. Um, so that is like the most basic, perhaps, state machine that we learn. And you can use Quint to define that, just define that state machine. Usually, state machines are more complicated than that, and if you want to draw the whole state machine, that can take a while. For example, if you have an algorithm that just increments a number, so you start from zero, and then you go from zero to one, one to two, two to three. If you want to draw circles and arrows for all of that, you'll never finish because there's too many. There are infinite many. Sorry. While in Quint and on TLA, you can just do say you have a state variable called x, and then you say x in the next state is equals to x in this state plus 1. So you write x prime, x with the tick, x prime equals x plus 1. So, and then you are defining this whole state machine, basically, because for every pair of, so for every transition in this thing that you draw, it satisfies this predicate of like x in the next state is equal to x in the current state plus 1. So it's basically a very powerful language to define state machines, and that's it. There's nothing more. And then actually there's one thing more, which is the properties, but the properties are not the model. So your model is just a state machine, and then you verify properties about the model. For example, in the traffic lights, if you have two simultaneous like traffic lights operating on the same crossing, you don't want never for the two of them to be green at the same time, right? Because if there are the two of traffic lights are green on the same crossing, cars will hit each other. So that's your property. Like traffic light 1 cannot be green and traffic light 2 cannot be green at the same state. So you write that to define your model with two traffic lights, and then you ask like a model checker to verify the property for every single state. And then that's what it does. So that's like a simple example, but you can expand that to like a decentralized exchange of X, and then like a bunch of people depositing money, withdrawing money, and all, and verifying properties about their balances and stuff.
I guess you explained why like math people love it is because like you just write an equation and then it'll cover like sort of everything infinitely. I guess could you go more in depth into comparing Quint versus TLA plus, or is that sort of like I think you already talked about sort of complicated? Any sort of examples or ideas that people can understand it?
Yeah, I can talk about like specific things that are different. So in TLA, you write things with math. So you write, use a lot of backslash. Oh, I have a good example. you know, and R, like the logic connectors and R, uh, on TLA plus, you write with how a logician will write it, which is kind of like the symbol here for and like this one for R, right? And on TLA, in order to type that, that's kind of Unicode. Recently, you are able to, I guess, from 6 months ago now on, you can write Unicode for TLA plus, but it's not super well supported with the input and all. So I'll talk about the normal version, which is the ASCII version. In order to type this symbol in ASCII in TLA, you write like forward slash backslash, right? And then the other one is backslash forward slash. For me, it's impossible. I don't know. I always like get them wrong, and I have to look at how the symbol looks, and then okay, no, this is an R. I actually want an and you have to write a bunch of N's and R's in CLA plus. In Quint, you write and R, like A and D and OR. So it's much easier to remember what you have to write, and also easier to type. And that's true for many other like operators. If you want to update. Say you have a list or an array and you want to update something at index 2 to value full. In TLA, you write like exclamation mark, square brackets, and then you'd write the index you want to update, and then except. Oh, sorry, except comes first. So except exclamation mark. So it's like it's hard to remember what you're supposed to write. While in Quint, we try to make things very like mnemonic and also close to mainstream languages. So if there is like a, a standard from mainstream languages on how you write and or R, we just do that in Quint. And for like, I guess for updating arrays, you have something like replace at, because it's not super, it's not very common you have to do it, but definitely like updating stuff, it's much easier in Quint because it's easier to remember. And also you have IDE tools that help you. So we have like auto-completion and that kind of thing. And it gives you feedback right away. So and this is kind of weird to talk here because this is what people expect, right? From programming languages. You pick up a programming language to learn, say Rust. Then you go to VS Code, you look up Rust in the bar there, download the extension, start using it. And then if you type something wrong, it will draw like a red squiggly line and complain and tell you what you're doing. And that's what we have in Quint. That's the expected thing. The thing is, you don't have that in TLA plus. So yeah, I love TLA plus. As I said, like I started working on this because I really like TLA plus, but it is there are some parts of it which are really hard to learn. So it's really hard to get started because you have to deal with all of this, and we just want to take all of that is good with TLA plus and then make it better with Quint. So I have lots of gratitude to TLA plus and the community and then to Lamport. But I guess the argument that Quint is better for programmers is something that's really kind of, it's not hard to make. If you just look at both, you probably choose Quint. So yeah, so I think the hard part is convincing people that they need formal verification at all.
Could you talk about the process of, I guess, using it for what is it, Malachite? Just
Yeah.
using Quint with that.
Yeah, I can talk a bit. I don't have like, a lot of context, but what I know is kind of like they have this uh, Tendermint Comet BFT implementation in Go, and someone wanted it in Rust, and but it's a very delicate implementation. Like it's a complicated consensus algorithm that has like a lot of nuance. So it was kind of scary. Just like look at Go code and write Rust, and then there was also the question of what is the source of truth then? If we have the Go implementation and the Rust, and then something diverges at some point in time, what is the correct one? What is the official Comet BFT one? So it started like this, and started like, oh, let's write a Quint spec then, and then the Quint spec is the source of truth. So they started writing like a Quint spec for what was in Go, and to then use that to also check the Rust code. I guess the point here, I have to introduce another concept that I've been mentioning, which is model-based testing. It's very important for the Malachite story. So model-based testing is actually, let me start with the problem. Model-based testing is a solution. Let me start with the problem. The problem is when you verify something with Quint or with TLA, you verified your model, but your model has no connection with your real world implementation. It has no connection with what is actually running in mainnet in production, right? It's just a model. It can be the modeling a different thing. You can make a mistake in your implementation or in your model by accident. Um, so that's usually like the first argument people have against the formal verification. Like, oh, you're not verifying the code, you're verifying this model. This model has nothing to do with the code except my thoughts of like, I wrote the code, I wrote the model, so I think they are the same, but I don't have any guarantee that they are the same. This is a problem with like complete solution, but model-based testing helps. So the model-based testing is you take the model, which is the thing you have verified that it is correct, and you generate a bunch of tests from it. So I spoke about the traffic lights. So say like I verified my traffic light model, and I ask Quint, Quint, please give me a trace of this correct model. And then Quint will give me a trace like, oh, the traffic light one becomes green, and then it becomes yellow, and then it becomes red. So it will give me an example of a successful execution. And then I can play that against my implementation by writing a test. So what we usually do is we take Quint and ask like, Quint, can you please give me 10,000 traces of this model? And then Quint will produce like JSON files formatted in like a specific way with these executions that are correct with the model. And then you have to be able to reproduce those JSON traces in your implementation. So you basically just write like call it like a harness code, or sometimes you call it glue code. But it's just an integration test or something that reads those JSON files, and plays them against the actual implementation, and to make sure that it's kind of like equivalent to the model, right? We are not guaranteed that they are equivalent because we're just testing like 10,000 traces as opposed to all of them, but it's like a good sign. So that's something we use Quint a lot for, and it's also like free tests, right? Who doesn't like free tests? You can get free tests with Quint. Yeah, so for Malachite, we had like Go and Rust, and then the idea was we write Quint spec, and then we generate traces, and it tests them against both like Go and Rust implementation. So I know they use Quint for model-based testing a lot in the Malachite project. Not sure how like this correspondence with the Go code was still important. I guess the project like diverged a bit from that, but they're still using Quint for model-based testing, and they use Quint mainly for the protocol modeling. So whenever they want to add something more to the protocol that like solves the problem, they, instead of going to the Rust code, which is super complicated and introducing like a bunch of stuff, they just add something on the model, which is usually much easier. So this is something also. So Lampard does this speech that I like a lot. Lampard says, "Who builds a building without the blueprint before? You first write a blueprint and then you start building, because it's very hard to like, if you want to change something, it's much easier to just redraw the blueprint than to like break a wall and build another one, right? And for programming, this kind of seems like it's not the case. Although changing code is also easier, but in fact, it is not. In fact, changing code is very costly, especially code that is already running in production. When you change code, you have the risk of introducing new bugs. So Lampard makes this argument of like using the model as a blueprint for your code, and then you change it and play around with it before trying to go to the actual code and change that, because it's much more costly.
Yeah, that is very cool. I understood that formal verification and like security is very important, but like I have no good understanding of like just how it works in general. Is there any sort of misconceptions or ideas or anything that like I didn't ask that I should have been asking or don't know about? Any unknown unknowns?
Hmm. Not sure. I guess a misconception that most people have um, is that it's just a button that you can click, and then it's all good, and then you're good to ship. Like it takes a skill, right? And that's actually something that we offer at Informal. Like we offer the service of like we'll go there and we write a specification for you, and we'll like generate tests for you, or we'll try to verify this part. Um, So there's definitely some skill that is required to learn in order to achieve that. Uh, but I also, uh, it's people that come for the formal verification, they often don't realize the benefits that come from Quint before the actual formal verification. And I think we didn't even realize that. Like when we started Quint, like the focus was formal verification, formal verification. Um, and the first thing people usually ask when they are learning TLA Plus or Quint, not I guess not Quint, like at the time, right? When we are conceiving Quint, the thing people ask when they are writing their first TLA model, like I'm here, I write my traffic lights model in TLA Plus, I define everything, and now if you are teaching me TLA Plus, I ask you, okay, how do I run it? Where do I click to run this thing? You don't run it. There's no way to run a specification. It's just a model. How do you run a state machine? You don't. The only thing you can do is get like right, you either model check, right, the entirety, which is the only thing you can do in CLA Plus, or you get a sample run. You get like an example of a possible run. So how do you run a DeFi? Like in a model of a DeFi, you get like an example. Alice transfers 100 Atom to Bob, then Bob withdraws 50 Atom. Like that is an example, but it's not like the run. So you introduce that to Quint, and you actually have a way. There is a command Quint run because that's what people expected, and then you just get some examples of things. So that's we just created that to solve this problem, but turns out Quint run has been like the most useful command for us. Most of the bugs we find through the Quint run command. Um, and it helps us understand. You didn't expect this, but Quint helps us understand protocols and code so well, and it's becoming our next pen and paper. I guess for me personally, like I didn't understand a lot about like distributed systems and consensus protocols a lot, but last year I was asked to kind of like, oh, could we write a Quint model for this super complicated consensus protocol? And I didn't even know basic consensus protocols, but I like, yeah, that's sure, I'll try. So I grabbed the paper and I was like reading the paper and writing Quint, reading the paper, writing Quint, and it was a great experience for me. Um, and there was another instance where I was asked to help on a project where was about a DEX, a decentralized exchange. The neutron DEX actually. So there was another colleague working on that, and I was asked to help. Um, and I didn't even know what a desk. Sorry, I didn't even knew what a DEX was supposed to do. I had no idea like how it worked. And then this colleague just explained briefly to me the idea, the concept, and then I just jumped into the spec. And like under a day, I understood everything that it did. Like it was so easier to understand like this concept through a spec. So I actually also believe that it can become kind of like a tool for onboarding. We can integrate it with different things. Like we have plenty of ideas on how it can become a tool for that, but I definitely believe that it's just kind of it really helps you understand. It's not just about formal verification. Uh, it really helps you understand the protocols. And the original idea by Lamport, right? A precise way to define things. How many times do we go to read documentation and find that the documentation is outdated or the documentation is not precise? With Quint, there's no way that it is not precise because it forces you to be precise, just as Lamport did TLA Plus to force people to be precise in papers. But it's also like it can be a live document. It can be a live document because you can integrate that. You generate tests from that specification, and then you can run that against your code. So you are sure that your documentation that is documented through Quint works like that. So that's a bit new. We are starting to use Quint as documentation internally. Like you can find some Comet BFT documents that are partially like written in Quint with like literate programming, partially written in Quint, partially written in English. Um, so it's really like becoming the next pen and paper of people that are getting used to using Quint. So I definitely think it's worth picking it up, even if not to make formal verification.
Uh, I guess in that case, whenever you sort of write a white paper or like you write a protocol, would you then use Quint to specify sort of like how it works? Is that like a
Yeah,
good understanding?
yeah, exactly.
Okay.
Some protocols write pseudocode in the papers, and pseudocodes actually also have mistakes because they are not executable. So you can easily make a mistake in pseudocode, and it's very common. But in Quint, you like cannot make a mistake. If you're writing like your Quint in VS Code, it will tell you if you make a mistake. So it will be precise and it will be correct. Um, and it's easy to understand. So if you write your, to I don't know, you want to establish a new protocol for scheduling a podcast. So you say like, oh no, first you have to come to me and then tell me this information, and then I'll evaluate and then I'll tell you that, and then we'll exchange messages, exchange email addresses. I don't know. You can write the whole protocol in Quint, you can verify stuff, and then you can post your white paper about how that's the best protocol for scheduling podcasts. I wrote a clean specification for drawing secret Santa names, and I made a case that one approach is better than the other. So you can find that blog post somewhere. Yeah.
Okay, that is very cool. I think whenever you described it, like just like the blueprints, and then it sort of connected like specification language. That's what it does. Uh, I guess it's time to wrap it up. Is there anything else I'm missing?
So on the topic of like using Quint for understanding things and as an expanded paper, there's one very nice thing that the simulator or also the model checker, but you don't even need a model checker for that. It can help you with, and I think that's really cool because you can ask Quint like, can you give me a scenario where like Alice has 53 atoms? Like it's very specific. Like I'm trying to debug some sort of thing, and then I can go to Quint and ask me like, run a bunch of things and reach a state where this happened, and then I can debug from there, or I can evaluate some stuff on that scenario. Where which like in production you cannot really do. Like you cannot like go to the blockchain explorer and like run a bunch of transactions until I reach this state. Or even on the test net, it's really hard to get like the fuzzers up to this stage, right? Um, so yeah, Quint does some fuzzing and then you can ask it to get some specific scenarios. And I actually used something like this to verify assumptions once. I was studying like the interchain communication protocols, the ICS. I was doing ICS 20 at a time, and I was like, I reading the documentation, there was like some assumption about how the channels worked. I'm like, why? Why do I have to follow this assumption? Why can't the channels be different? Uh, so I went there and I modeled two versions. One in which the channels behaved like they were supposed to under the assumption, and other where the channels were just anything. There was no like rule about the channels. And then I asked the simulator to find a scenario where that was a problem, and then it gave me a scenario. And I was like, oh, that's why. So that's what happens. Okay, now I believe this assumption, and got back. So this is an exercise that we do all the time. I guess when we have the Quint model, we just play like, oh, give me a scenario where this type of transaction happened. Give me a scenario where uh, first Alice deposited and then Bob withdrew. Like we can go very creative, and then you can actually also generate the model-based tests based on those hypothetical scenarios that you create. Like, so give me tests where Bob loses all his money. Give me tests where there's profit for the contract. Give me tests where this happens, and Quint will give you. So yeah, it's a very interactive tool as well.
Anyways, thank you so much, Gabriella. Whatever the podcasters say at the end, call to action. Anything use Quint or
Yeah.
any? Yeah, tell me about it.
Yeah, so we can find everything about Quint in the Quint website, quint-lang.org. And we also have a Telegram channel if you want to ask any questions. I am way too excited to talk about Quint, perhaps you noticed. So whenever you want to like ask questions, or if you want to try Quint for a new project and stuff, and you have like a spec you want me to review, please reach out. I'm super happy to help. I'm very excited. And so you can reach out to the Telegram channel, or also through Twitter or in the GitHub. You can follow me on Twitter because I tweet about Quint a lot. So it's Bugarella, my tweet. I guess you could put that somewhere. So yeah, Quint website, Telegram channel, and perhaps follow me on Twitter. And come to me if you want to talk about Quint, because I love it.
Anyways, super fascinating. Quint sounds cool. Thank you so much for hopping on.
Yeah, thanks a lot. It was very fun.